Hi, everyone. My name is Inbal. I'm a data scientist at Gong. Today, I'm going to talk about topic segmentation of conversations using unsupervised models. I'm going to be presenting along with my colleague, Eran. So a little short overview of Gong. Gong is a revenue intelligence platform that aims to that helps decision makers and frontline managers gain visibility into sales processes and other customer-facing interactions. So we capture phone calls, web conferencing, email, CRM data, and we analyze this and help give actionable insights to help sales teams perform better. So we were founded 4 years ago. We have 260 employees in 2 sites. We've raised $130 million to date, and we serve well-known brands like LinkedIn, PayPal, GE, NASDAQ, as you can see in the photo, and more. So say I'm a sales representative. I had an hour-long call with a prospect. I could record it, and then it's a little bit difficult to make sense of all of this. It doesn't scale well to listen to this conversation, to all of these conversations that I've had. My team manager definitely can't listen to all of the conversations of all the sales representatives in her team. So what Gong does is adds layers of understanding to these calls. For example, who spoke when, what was said, what was shown on the screen, how did this conversation progress, and what did we even talk about? This talk is going to focus on the former two, how did this conversation progress and what was discussed. This is part of a screenshot of our call screen. We see in the top 2 rows, not working. Okay, the purple line at the top is the talk track of the sales representative, and the pink or red, depending on your opinion, is the prospect talk track. Below that, there's a yellow bar that shows the progression of the conversation into parts. Below that, topics that were discussed in the conversation, and then the 4 purple bars at the bottom are what was shown on the screen during the conversation. So I'm going to zoom into certain parts of this and explain a little bit more. So here we see the part that's the segment that we marked as discovery. Discovery is a well-known part in a sales conversation. This is where ideally the sales representative will ask the prospect what are his needs, what are the pain points, getting to know the prospect and see if there's a fit between the two. We see that this part correlates very nicely with the video that was showing the camera, which was showing the faces of the participants, and a presentation, because oftentimes sales reps come with like a with a slide deck that they prepared beforehand. Topics that were discussed here are discovery and value proposition. In another part of the conversation, this is the pitch. This correlates very nicely to to the, sorry, the text here is wrong. This correlates well with browser, which is a browser demo. Topics that were discussed here are more feature-oriented, like stats or topics. So now that we have this layer of understanding, what do we do with it? So we'd like to take it from just basic understanding to actionable insights. So as you could see earlier, it helps in navigation. I can jump straight to the places where we discussed pricing, or straight to the parts where we discussed a certain feature. We can extract meaningful statistics. For example, the number of prospect questions during the demo, where a higher number of questions means that the prospect was engaged. That may correlate with the fact that the deal is going well, or if there aren't many questions, maybe the deal isn't going so well. In terms of coaching, I can see what my top performers are doing and give insights and recommendations to my bottom performers. For example, successful sales representatives talk more about pricing and talk less about compliance. I can also give managers alerts. For example, show me all of the very large deals that are in the negotiation step, but there were no next steps discussed in this conversation. Or maybe the competition that came up in a pricing discussion. The models that we use we're gonna describe two models: a topic model and a call structure model. And these aren't standard models. These are patented technology. They're unsupervised, and they're trained per company. And I'm going to pass the stage to Eran, who's going to tell you more about topics.
Thank you. And Inbal will come up again at the end. So, thank you, Inbal. So I'm going to discuss the conversation topics, how we did that. So first, let's look at a call. So this is just basically a long stretch of words, and we want to make sense out of it. And as Inbal showed, what we specifically want is to give a bird's eye view into the topics and where each topic was discussed. So for example, in this call, we can see the conversation started with small talk, which is a natural thing in such conversations. And then we can also see, for example, that the pricing was mentioned twice. It came up twice in this call. So, okay, good. So we have our target, and we want to solve this problem, but we have a few obstacles. First, we don't really know where the boundaries of each segment are. All right, so we don't know where each segment starts and ends. And even worse, we don't even know what are the topics. This is not something that is given to us. And each company discusses different topics. And those topics may even change over time, right? So if a company starts selling a new product, they will start discussing this new product. So we cannot train on all the data and then hope it will be relevant for future conversations. Okay, so in order to solve all these problems, we need some model that can still find the solution. And let's assume for a second that we do know the topics, and not only that we know the topics, we also know the word probabilities for each topic. Okay, so now we have a much simpler problem. We just need to find the segments where each topic was discussed. So we can follow the following heuristics. We can break the conversation into small segments. Hopefully in each such segment, only a single topic is discussed. And then we can score how well each segment matches each of the topics. So what we used is a score which is basically proportional to the log odds of the probabilities. The probability of the entire segment coming up from the topic, from topic T, divided by the probability of the same segment emerging from the background probabilities. And once we have the scores for all topics for each segment, we can simply use something like choosing the maximal score up to some windowing or a few more hyperparameters, which I'm not going to discuss. So good, so we have our solution, but there's a small problem. I assumed we knew the topics and that we knew the probabilities for a word in each topic, and this is obviously not the case. So how can we find this? And we can maybe try to have human labelers tell us what the topics are and try to find out the word's distribution of each topic, but we decided to use unsupervised approach. So it has many benefits in our case. It needs no labeling, and actually a human labeler will not be able to label very accurately the topics in such a call. You can try to imagine this like a 50-minute or maybe more long conversation, trying to think where exactly did they start the small talk, what was the exact word that they switched to pricing. This will probably not be very robust. Also, using unsupervised approach, we can apply it and adjust it for each company separately, and we can let the topics emerge from the data. And we can apply it over and over, and the model will be adjusted to new topics that coming up or new companies. Okay, so for example, at Gong, we're going to talk about sales and stats and what we do, and a company like GE will probably talk about refrigerators. Okay, so what exactly unsupervised model we decided to use is called LDA. It's a familiar familiar model for such a problem. So LDA stands for latent directly allocation, topic modeling, and for those of you who don't remember or know LDA, I'm just going to have a quick recap of what LDA is. So LDA is a probabilistic generative model, and this is the basic framework of such a model. We're first going to describe how the data is created, and for LDA, the model assumes there are documents which are mixture of topics, meaning, for example, the first document is 20% animals and 80% tech. And each topic is a mixture of words. So a dog, for example, and cat are going to be more dominant in the animals topic. So this is how the data is described. And then we're going to use the actual data that we have in order to, as evidence, in order to find the best parameters that match the model. Okay, so that's good, and we have all the words because it's just the text of the call, and this we have because we are applying ASR. But what are documents in our case? We didn't discuss documents, we discussed conversations. Right? Is a conversation a document? Well, it turns out it's not really a good idea to just take entire conversation and use it as our documents. Even though we have millions of conversations, it's just not going to fit because people talk in conversations about pretty much everything. And the whole assumption in LDA is that documents are distinguished in the topics that are mentioned in each document. So each document is a collection of a few topics, and those topics change between one document and the other. So this is the bad part, but there is a bright point, because people don't typically change topic all the time. So we can take the long conversation, break it into smaller segments. Okay, those segments don't necessarily need to match the segments I mentioned before. And we can use each such segment as our document in the LDA model. Okay, so you can see an illustration of this here. And now we need to describe, again, how the model, the data is created. So for a generative process, we are going to imagine a process that creates the data. This is obviously not going to be the way the data is created, but it's a good approximation, at least for our needs. So the process goes like this. For each topic, we're going to draw word distribution for this topic. This is being drawn from a Dirichlet distribution with a beta prior. And then for each document, we're going to draw a topic distribution. So again, for example, 0.2 from the first topic and 0.8 from the second topic. And then, once we have the distributions of topics in each document and distribution of words in each topic, we can just start generating words and generating the documents. So for each word, we will first draw the topic, and then, given that topic, we can actually draw the word itself, whether it's dog or anything else. Okay, so we have the generative model. We have the description of the data. And I remind you that what we wanted is to find the word distributions per topic, and obviously the topics themselves. So those are the parameters of the model, and we just need to train or use inference in order to understand which parameters of such a model would fit best the actual data that we have. Okay? So one way of doing this is using Gibbs sampling. Okay, this is one way of doing this. There are other options. And Gibbs sampling operates in the following way. We start with some initial state in which we just draw a random topic for each word. And then we iteratively freeze all the assignments, take one word at a time, and delete the assigned topic. And then we redraw a topic for this word. Okay? So, and we do it iteratively for each and every word. So each word will be given a new topic based on the probability of this word belonging to such a topic, and this topic belonging to the document where the word is located. So this is an iterative process, and then it will finally converge to a sample that represents well the target distribution. Okay, so we did this, and if you have questions about how LDA works, you can come to me later. And but what we do have now are distributions of word in topics. Okay, so let me get back here. So for example, in topic 1, we see the dollar is much more dominant in this topic, and topic 2, calendar, is have a bigger probability. Okay, so but how do we know that these topics that we got are meaningful or relevant for our needs? We just have topic 1, topic 2, etc. So one way is to simply review the topics themselves. We can see which words were given higher weight in each topic. For example, here topic 1 had the higher weight or probability for the dollar and price words, so it's probably related to pricing. And topic 2 had words, dominant words like calendar, invite, next week, okay, engrams also. So next step, will be a good name for this topic. Okay, so we are concentrating on the output of this algorithm, and we can make sense out of the topic. But sometimes this is not enough. Sometimes we wish to find specific topics, and we don't want to just let chance let those topics emerge or not. For example, we know pricing must be there because every company that sells something will discuss pricing at this point or another. So what we can do is actually intervene in the first part, in the initialization, and we find that if we just increase the weight of specific words, for example, dollar and price in topic 2, we can guide the process and help the process converge in a way that this topic will be about pricing. Okay, and we can also sometimes make it converge to topics that are will not necessarily be there if we didn't do anything at the beginning. And the last thing I want to discuss is decluttering topics. So we have the conversation. It's been broken down to multiple topics, but this just makes too much clutter. Okay, so it's good for statistics, and it actually corresponds well with the reality, people, if you listen to the segments here, you will agree mostly with our topic assignment, but this is just too much clutter for a human to understand what's going on if he just looks at this. And one way to solve this is just to reduce the number of topics, right? So why use so many topics? But again, this is the problem with LDA. If we just use too few topics, those topics will be just too fuzzy. They won't be well defined, and that's actually a problem. But what we can do, another solution that we use, is just to cluster the topics. Right? So the topics are clusters themselves, but we can cluster the topics into higher order of clusters. And for this, just remember each topic is described as a word distribution over just a vector of word probabilities. So we need, in order to apply such clustering, we need to use some distance over a distribution space. And for example, Jensen-Shannon distance is a good metric for this purpose. And last, just a few examples of how well it works. So for example, if we apply this clustering, we get that integration and account setup are clustered together, and those are related to technical issues. Value proposition, differentiation, those are also clustered together, and I can say it's like why us, higher super topic. And topics themselves, topics is a topic in Gong, and stats are actually features that we talk about, and those are all clustered together. So now I will let Inbal continue with the conversation structure. Thank you.
So another related model is something we call conversation structure. It's another way of making sense of the conversation. So sales representatives, they often follow structured sales methodology. So a conversation has a few stages that it goes through. You start with meeting setup, chit-chat, talking about the weather, talking about sports maybe. Then the discovery, like I explained earlier, followed by the pitch, where I tell you about the product and how amazing it is, and we have an interactive demo, followed by assessment, where the prospect may raise some objections, ask some more questions, talk about pricing, for example. And hopefully, if all goes well, there's going to be a next steps where we set up another time for a next meeting, conversation with decision makers and all that. Now, the question arises is how do we automatically find these different parts of the conversation, and how do we segment our conversations? Or in other words, how do we learn a company playbook that's suited and tailored specifically to each company? So the method we used to solve this problem is the same mechanics, the same generative probabilistic model. And in this case, our data is described as follows. So first, I draw a distribution, theta. This is going to describe the length of my segments. So, for example, discovery is going to be roughly 20% of the conversation. The pitch is going to be about 50%, etc. For each segment, I draw a word distribution. And then, once I have these in place, I create my documents. So I break them up into paragraphs. For every paragraph, I draw a segment assignment. And once I have that segment, I draw my words from the corresponding word distribution. Now, since I assumed that my conversation goes through these stages sequentially, I need to enforce this order. And so after I have my paragraphs, I then sort them in the predefined order. So I can think about this a little differently, in a more simple way. I can think of this as a conversation being a long stick, and I need to break this stick up into different parts. And essentially, I just need to decide where to break it, where each segment begins and where each segment ends. So I can introduce prior knowledge into my model by using different values of parameter alpha. And you can ask me about this later. Here in the sampling, ask me about this later as well. I don't have, I'm over time. So I have my call. It was segmented like so. How do I know if this is a good fit to the playbook that we learned? So the probability for the segmentation is composed of two parts. The first part is the probability that this paragraph. Okay, I'm being told that I'm way over time. Okay, I'm just gonna. This is gonna take a bit too long. Ask me about this later. But we. Just in conclusion, we described two models, a topic model and a conversation structure model. We showed how these two models provide value to our customers. Thank you.